Okay, on to section 7.3, confidence intervals for the mean. So the idea is we're going to be making confidence intervals that look something like this. This says the mean is somewhere between 80 and 84. That one right there could be something like the average temperature in Maui, somewhere between 80 and 84. Well, if you find the number that's in the middle of 80 and 84, that's going to be an 82. So what this interval is basically saying is the average is 82, but it could be off by plus or minus 2. So if you add 2, you would get the 84, and if you subtract 2, you would get 80. So this is called the error of the estimate. This, in this case, would be 2 degrees. Our main job in this section is going to be calculating how much is the error. So we'll be given sample information, the mean, standard deviation, and sample size. And with these, we're going to create a new parameter, which is called t. The formula for it is almost exactly the same as it is for z, although down here, we're dividing by the sample standard deviation instead of sigma. Other than that, it's the same as z. Okay. But since we're not using z, that means that we can't use table A2. So the good news is we get to use a whole new table. That table is called A3, and this is what table A3 looks like. So table A3 is actually even easier to use than table A2. One thing to notice is here at the top of the table, it says 2 tails. In this chapter, chapter 7, we're only going to be using the 2 tails, because that confidence interval had a left side and a right side. It said it went from 80 to 84, so it's got 2 tails. In chapters after this, chapter 8 and 9, we'll use the 1 tail part. This chapter, just the 2 tails. Then the other thing over here is degrees of freedom, which is simply n minus 1, the sample size minus 1. So once you decide, okay, I'm using 2 tails and 0.05, then you would just go down to whatever the degrees of freedom is, and then that's the critical value. And then it would be plus or minus that number. So we use the positive and negative. So here's an actual example. If the sample size is 43, and we're using 95% level of confidence, all right, get our table A3 here. 95% level of confidence means alpha equals 0.05. So we'd be using this middle column where it says 0.05. Then degrees of freedom is going to be 42. So then over here, go down to where there's 42. And you'll notice that it doesn't have a 42. Well, with all of these tables, whenever they don't have exactly what you need, you just use whatever's closest. So the closest that we have is the 40. So we'd be using 40 and go over to the middle column, and the critical value would be 2.021. And then that's called t sub alpha over 2 because the 2 tails. So this is saying that was 2 tails. Okay, now the formula for the confidence interval goes like this. So you take the mean plus the error, that's the right side. The mean minus the error is the left side. And the error is calculated with this little formula right here. You use the critical value that we just got, the standard deviation, which you would be given, divided by the square root of n, and you would also be given. Here's an example. So if n equals 37 Hartnell students, asked how many hours they worked. So here's the sample mean, 16.07, and S equals 14.18. Now make the confidence interval for how many hours they work per week. So we need, well, I like to write down the information just to organize my work. So there's the N, X bar, and S. Degrees of freedom would be 36, and then use the table. So we're using 98% confidence. That means alpha equals 0.02. So we're using this second column right here. And then degrees of freedom is 36. So that is a 2.434. So the critical value, 2.434. Then just do this little formula for the error. So here is the critical value, S, divided by the square root of n, 37. Type that in the calculator and you'll find the error is 5.674. That basically means people work an average of 16 hours, but it could be off by plus or minus 5.6 hours. Here's where the plus or minus comes in. You add the error on the right side, you subtract the error on the left side, and then you get the final interval, saying that Hartnell students work somewhere between 10.396 and 21.744 hours per week. You can also do this on the calculator, and on tests and quizzes, I would prefer that you use the calculator, and it would look like this. So you go to Stat, move over to Tests, scroll down until you find T-interval, type in the information that was given. You don't even have to type in the critical value. The calculator will calculate that. Confidence level is 98. And then there's the interval, 10.395 to 21.745. Now, the calculator is actually a little more accurate. These numbers in here are a little more accurate because it finds the exact critical value accurate out to 13 decimal places. So not only is using the TI-84 easier and more fun, it's also more accurate.